Question 1. The 12th term of an arithmetic series is 41 and the sum of the first 16 terms is 488. Find the first term and the common difference. So you just need to make sure you're using the right formula. So when it says the something term, then you're going to use a plus n minus 1d. So the 12th term, we're going to write a plus 11d for the 12th term, and that equals 41. If it talks about the sum of the first so many terms, then you can use the sum formula. Okay, there are two versions of it. You could also use n over 2 bracket a plus l, where l is the last term, but it's not very likely you're going to know the last term. It's more likely you're going to use the a and the d here. So we've got the sum of the first 16 terms, so n is 16. So we're going to say 16 over 2 bracket 2 lots of a, we just don't know a, n minus 1 is 15, so that's 16 over 2 bracket 2a plus 15d, and that equals 488. So those are our two equations, and then we have to simultaneous them. So if we tidy the second one up as much as we can, 16 over 2 is 8. We could times out with the 8, or we could divide the 488 by 8 that way. So maybe that's a nicer way to do it because it keeps the numbers slightly smaller. So 488 divided by 8, 61. I know I could do that in my head. So we've got equation 1, and now we've got this tidied up equation 2. Okay, and again, at this point, it's up to you how you carry on. I often will rearrange if I can see one letter in its own that I can make the subject. So I could say a is 41 minus 11d and substitute that in to the other equation. So I'll get two lots of 41 minus 11d, add 15d equals 61. Two 41s are 82. So multiply out that bracket. So that gives me 82 take away 7d is 61. Okay, if I hop the 61 back and hop the 7d to make it positive, I'm going to do 82 take away 61, which is 21. That gives me d is 3. You would really do expect a nice-ish answer with these questions. Substitute back in. 41 minus 33 gives you 8. So the first term is 8 and the common difference is 3.